A polynomial occurs when you have whole number exponents. Whole number exponents. You have talked about two specific polynomials so far, possibly three. And they're going to be below. Constant function, and then we go linear and quadratic. But I'm going to give you those examples for now. One of them would be like y equals 7. That's a constant function because if I give it a variable, the variable I would give is x to the 0, right? I can write anything to the power of 0. What's anything to the power of 0? No. 1. Anything to the power of 0 is 1. And when this is introduced was grade 9. How do I know that? Because my kid's in grade 9. So x to the 0 is first introduced in grade 9, which is to the power of 1. The reason why that is, let's remind ourselves. If I do 7 squared, let's work our way backwards, okay? 7 squared is what? 49. We agree? 7 times 7? That's taught earlier than grade 9. 7 to the 1 is what? 7. So that's 49 divided by 7 is 7, correct? 7 to the 0 would be 7 divided by 7, which is 1. Anything divided by itself is 1. Remember, you cancel them off and you're left with 1s? Then, in grade 10, you were taught about 7 to the negative 1, which is 1 divided by 7. So 49 divided by 7 is 7. 7 divided by 7 is 1. 1 divided by 7 is 1. 7th. You were taught you could move this to the denominator and become a positive exponent. Remember that? Grade 10? Well, now you know. If it was 7 to the negative 2, then this would be 1 over 7 to the positive 2. Because we can move it, remember we can make exponents by moving it to the bottom, which would be 1 over 49. So you're dividing by 7 again, right? Which is multiplying by 1/7. So that's why this one ends up as a 1. Do you see the pattern? Yeah? Okay, let's go back. So this would just be 7 times 1, which is 7. So that's why they don't have to write x to the 0. But that's a constant function. In grade 10, another example we started talking about was linear. So y equals like 3x plus 6. And then I say, well, it has to have whole exponents. Every single term has to have whole exponents, correct? So this one, x is just to the power of 1 if it doesn't have 1. And then this one would be x to the what? X to the 1 would exist. So what would this be if there was nothing here? X to the 0. I can write x to the 0 on anything if I want to. What's x to the 0 just? 1. And when you multiply by 1, what does it do? Nothing. So this has a 1, this has a 0. Then we learned about quadratics. Y equals 3x squared plus 6x plus 4, let's say. So this is a whole exponent. It's a 2, right? Remember, whole numbers are the numbers, the natural numbers plus the one with a whole. This is to the 1. What would this one be that doesn't have 1? X to the 0, right? So they have whole number exponents. The last one we're going to learn about this year, because we can only go up to cubics. So this is constant, linear, quadratic. We could do cubics. Just has to have an x cubed. So it could be like negative 3x cubed plus 6x squared minus 4x plus 7. So this would be 3, 2, this would be a 1, that would be x to the 0, right? So it would have whole exponents. And then we stop at cubic. So we only add one extra one this year for you guys. 30-1 adds up to degree 5. It's degree 1, 2, and 3. They have 4 and 5 as well. What is not a polynomial? So what's not a polynomial is one that has an exponent that is not a whole number. So an example could be like y equals 3x to the 1 decimal 3. That would be not an exponent. That's not a whole number, right? And I could add everything else to it. It'd be still 6x squared plus 3. That's all fine, but the 1.3 immediately crushes this because that's not a full number. Yeah? Another one we could have would be like y equals 2x to the 3 halves. That wouldn't work either because 3 halves is 1.5, right? That's a rational, not a whole number. Another one could be an integer. So I could go like y equals 3x to the negative 2. This wouldn't work either. That's not a whole number, right? Another one could be like y equals x to the square root of 3. That's not a whole number. What is a polynomial that throws people often though? Often is this. So this is a polynomial. Y equals square root 3x squared plus 6x. People will tell me that's not a polynomial. What's the only rule about polynomials? It has to have whole number exponents, not coefficients. So this one has a 2, this one has a 1. That passes, right? So if you watch yourself. Another one that isn't is like y equals root x. Because that would be x to the half as well. So that would be. A constant function is just a number like y equals 3. So if I went to sketch that one, it's a horizontal line because y equals lines are horizontal lines and x equals lines are vertical lines. So if I go to 3, my dash is going horizontally, correct? See that? So this is where y equals 3 the whole way across. Here. Come on. So constant functions are horizontal lines. See that? Make sure you're filling it in. What is the domain of this? And if you did set interval notation in 20-1 where it was the brackets, say goodbye to it. You can only do set notation. Squiggly brackets. So in 20-2 you would have only done squiggly brackets. So can you only do that in 30-2? You can't do the like 1 to 2 square brackets, round brackets. Can't do that. Interval notation is out. So if you were coming from -2, you only know this way, so you're golden. -1, you can only do this way. So are there any x values that don't exist on this graph? It starts at 0 and it goes out for life to the right, to the left for you, and out for life to the right. Do all the x's exist? If I can just go like this? Yeah. So what is that in domain? Remember? X such that. Pardon? X is an element of the reals. So you go squiggly bracket. The reason why you do a squiggly bracket is the squiggly bracket means the set of. A round bracket means something totally different. Square bracket means something totally different. Squiggly bracket in mathematics, they're called curly brackets. I call them squiggly. I don't know why. They're called curly brackets. The curly brackets, if you open one up and close one, means the set of. Literally, it's terminology. Okay, the set of. Then I need the variable x, his domain, such that. That straight up and down line means such that. So this means the set of x values, because I'm dealing with domain. Now, if I was doing like y equals ax squared plus ax plus 7, and I made a be the x now, I would actually have to put an a here. So it's whatever the x variable is, you have to change it to. Okay. Sometimes that happened. Let's think about this in 20-1, 20-2, when you guys did quadratics and you did h of t equals t squared plus 3t plus 1, and your t was the x. You should technically have had t's here as well. So it's x such that x is an element of the real numbers. So when all the values exist, it's element of reals. What y values exist on this graph? 3. That's it. Are there any other y's on here? They're all just y equals to 3, correct? So my range is going to be y such that y equals 3. That's it. You're often not given a constant function anyways. We just discuss it so that if you were, you would know. Okay? Flipping over. Going back into grade 10 land. What are these? Linear functions. What are linear functions? Straight lines, right? Grade 10. That's all it is. So I'm going to give you two equations. So degree 1 function, it's a degree 1 because the largest exponent on this equation is a 1. That's how we know it's a degree 1. And it's called linear. And I know in grade 10 we talked about mx plus b, but in grade 11 and 12, you'll go a, b, c, d, e. There's no m's anymore. So a in this case is the slope. Okay? Yeah. So we're going to look at y equals 3x plus 4. It's the first one we're going to look at. We're going to draw ourselves a little graph. So the b value is 4, correct? The b value is 4. Does anyone remember what the b value represents? The y-intercept? Why is it the y-intercept, though? When you say y-intercept, what should immediately pop into your head? X equals what? 0, correct? So in this equation, if I put 0 in for x, so if I wanted to find the y-intercept, I would go x equals 0. I would get y equals 3 times 0 plus 4. So if my equation, it doesn't have brackets, every other part of it's going to go away because I'm going to fill 0 in for the x's, right? And 0 times anything cancels. So I would get y equals 4. So it's 0, 4. So if we're looking at it in standard form, which means no brackets, our back number will always be our y-intercept. So I'm going to plot that first. Then from 10C, we were taught about the slope. The slope was always what was in front of the x, right? So I know my slope, my m, is 3. Now, with slope, it's like getting out of bed in the morning. Do you run before you rise to get out of bed? Or do you rise and then run? If your alarm clock's late, you rise. If you slept through, and then you run. You don't run and then rise. You're literally just running, and then you stand up. That makes no sense, correct? So just like slope and you getting out of bed in the morning, you have to rise before you run. So it's up, down, before left, right. Rise before you run to get out of bed. So I need another number. So it's going to be over 1 if there isn't one, correct? So I'm going to rise before I run. So if it's a plus 3, I'm going to rise up 3, correct? And then if it's a plus 1, I'm going to run 1 right. Then I'm going to show you how we can go the complete opposite. So this is up 3, 1 right. So I'm going to go from here, and I'm going to go up 3, 1, 2, because this is my starting point. I'm going to go 1, 2, 3, up 3, and then right 1. So currently I have this. Which is lovely. If I keep going, I'm just randomly drawing a graph without any coordinates, correct? So up 3, right 1 was great, but I ran out of space. You can also go the complete opposite, and I'll show you why. So 3 over 1 was what was given to me. Yes? The complete opposite would be, instead of up 3, right 1, I would go down 3, left 1, but why? We should always ask why. If I make this negative and this negative, what's a negative divided by a negative? The positive. So that's why you can actually go the complete opposite. So instead of going up 3, right 1, I could also go down 3, left 1. Let's see, and it should still land on the same line, correct? So if I start here and I go down 3, 1, 2, 3, left 1, am I landing on the same line? Yep. Then I go down 3, 1, 2, 3, left 1. Come on. Then I go down 3, 1, 2, 3, left 1. Oh my goodness. Down 3, 1, 2, 3, left 1. And then I can extend. Why is my graph not perfect? Because I freehanded the entire graph. That's why it's not perfect, right? On a test, you would be given a Cartesian plane to fill in. So I would suspect that you would either take the calculator lid off your calculator or something, put it on there and draw a straight line, right? I don't want it looking like your graph should not look like you were riding on a bus going over the speed bumps that they put in the back parking lot. Those are aggressive. Coffee spilled every morning. I was talking to my daughter on the phone this morning. So, I'm going to give you guys a second one on the other side. You're going to try and draw it. Okay? Go. Go. So if we draw this one, guys. We have 1, 2, 3, 4 is our y-intercept, right? Now, in grade 10, when I used to teach grade 10, which was a long time ago, I realized both my children have been born after I taught grade 10. So, and my oldest is 14. So it's been a while. But when I used to teach it, everyone used slope from 0, 0. Think of slope like it's like your steps you have to use on a map, okay? So like, for example, this slope, I'm going to either put the negative here or the negative here. It could be either one, right? That's how we can go in opposite directions. So if I leave it on the top, it's going to be down 1 and then right 2, correct? Those are my directions that I have to go. I have to go down 1, I have to go right 2. What you have to remember is your teacher also has to give you a starting point. So what happened in grade 10, because I didn't explain it as well, they would always start at 0, 0, and then they would go down 1, right 2 from 0, 0. But 0, 0 isn't always the starting point. Your teacher has to give you a starting point. Your starting point for all of these is the y-intercept, right? So I'm starting, this here is my y-intercept, aka my starting point. So I'm starting here, and then I use the directions from that point to draw the rest of the graph, yes? So, I need to go down 1, right 2. Down 1, right 2. Down 1, right 2. Can I go the complete opposite? I could go up 1, left 2, and I'll land on it, because if I put the negative on the 2 and the positive on the 1, it would take me the opposite direction. And when you connect them, you get a straight line. Okay. What is the leading coefficient? The leading coefficient, just to help you out, is the number in front of the largest exponent variable. A lot of people think it's the very first number. It is the very first number if your equation is in order. So if you go from highest exponent, quickly. If you go from highest exponent to lowest exponent, your leading coefficient is the one that leads the equation. But if you have them listed out of order, like for example, if I had 4 plus 3x, my leading coefficient is still the 3. because it's the number in front of the largest exponent. It should lead the equation. You should go in descending powers at x on your variable. But if you don't, it's the number in front. So for this one, it's a 3. For this one, what is it? What's the number that leads it? Negative 1/2. It's in front of the x. What I want to tell you about the leading coefficient is it tells you how it ends, what direction it ends on the right. So this leading coefficient, because this is positive, do you see that? It ends up on right. You see it's ending up on the right? And this one here is negative. So what's it going to do on the right? And what? Up or down on the right? Down on right. Okay. What's my y-intercept on this one? What's my y-intercept? It's written. What is my y-intercept? Guys, what's my y-intercept? 0, 4. What's my y-intercept for this one? 0, 4, same thing. Okay, I want to get through this. How many x-intercepts does this one have? 1, crosses through once, correct? How many is this one going to have? 1. So its minimum is 1 and its maximum is 1. It's a straight line. It has to cross through somewhere once. It doesn't curve back, so it can't cross through more than once. Yes? Because it discos, it has to cross through at least once because the arrows are in opposite direction. What's the domain and range of a linear element of the reals? Because it goes out for life to the right and the left, and it goes out for life up and down, correct? So every x and every y exists. So this one's going to be x such that x is an element of the reals. And whenever your graph discos, it's always XER, YER, because it's going out to the right and left forever and up and down forever. You should be filling these notes in. And being grateful you don't have to write it all out. Also open books with empty notes, not fun.